Hi, and welcome to the 15th installment of Grade 9 Physics. This is Sir CJ, and welcome to another video lesson. This video lesson is still under Book 20. However, we are moving forward to pages number 6 to 11. So medyo mahaba-haba ang session na to. Well, compared dun sa ibang mga sessions na ilang pages lang, this one is actually going to be about 5 pages long sa mismong 7E-based self-learning module in Science 9, which I wrote for my master rate. Now, this episode is divided into the following parts. Tagtatatlo lang to. So, the usual. The first part is under observe, the first kumbaga subcomponent of the 7E-based self-learning module in Science 9 chapters. Pero patapos na tayo sa first subpart niya. It's a discussion on the law of conservation of momentum. And then, the second part is under ask, the second subcomponent. And it will be a question formulation. So, a feature of this module which I really love about it is yung inclusion nung pagpo-formulate ng question na hindi lang actually ang teacher ang magpo-formulate. It's going to be the student themselves. Okay? So sila mismo ang mag-iisip ng mga questions that they might have about the topic so far. That is after they get some observation. So pangalawa lagi yung ask. Yan. And yung sample question natin dito is about what is the science behind collisions? When two bodies collide, how do they behave and how does physics explain that? Ganun siya. And then the next one is, the last part is under ask. It's activity number 69. It's titled Bouncy Balls. Let's now begin with the first part, the observe discussion. In this section, we looked back at how an object, such as a coin, can have an inherent momentum since it has mass and velocity. Now, let us have to make sure that we understand na yung coin na pinag-uusapan natin dito was actually that coin na gumagalaw, okay? Hindi yung mga coins na stationary. Alright? A coin that was moving in the previous activity has a momentum because aside from the fact that it has mass, it also has velocity or speed. Now, you have proven the presence of that momentum dun sa mga activities na ginawa natin at saka dun sa mga variations nung activity na yon. Now, with activity number 68, yung previous activity, you were introduced to the idea that when a moving coin that has momentum hits stationary coins, yung nakalinya, that do not have momentum, the momentum of the moving coin will be transferred to the first coin it hits, and then that coin will transfer to the next until the coin at the other end move in the direction of that momentum. So napansin nyo siguro ganito, dun sa linya na yun, kung halimbawa, yung pag-flick mo ng coin was towards your left, towards the left, tapos it hit a coin, tapos, yes, the momentum was transferred. Yung pinaka-last na coin dun sa hilera will surely be moving towards the left as well, right? Because that was the direction of the momentum, making momentum a vector quantity. Okay? Okay. Now, paano natin nasabi na walang momentum yung mga coins na stationary lang? Simple. The formula for momentum is mass multiplied by volume. Am I right? So, not volume, velocity. Okay, mass multiplied by velocity. Ayan, mass multiplied by velocity. If the velocity is 0, naturally, the product will be 0. Kahit gaano pa kabigat yung coin, gaano man siya kagaan, if it's not moving, it doesn't have velocity, it's 0. If you multiply them, you'll get 0 momentum. Alright? Okay, I hope that you got that. Now, when you hit the coins toward the left, the coin at the far end will move towards the left. That's what we were talking about kanina. But in Bawa, if the coin over here ito naman yung ginamit mo to hit the line of coins, surely the last coin over here, which is this one, will move towards the right. It's not going to move over, papunta sa taas o kaya papunta sa baba because the momentum, the application of the momentum was towards this direction. All right? Okay. Now, consequently, when you hit the row of coins towards the right, the coin at the far end will move towards the right. That's what I was talking about. Now, if you get two coins, and if you try and collide them by pushing them towards each other with the same amount of effort, what do you think is going to happen? All right. Now, I want you to write your observations on a piece of paper. Okay? And then, compare observations dito sa scenario na to dun sa mga scenarios na ginawa na natin before. Now, what those instances tell us is that the momentum of an object is not lost, hindi siya mawawala, when it hits another object that may or may not have a momentum. Dun sa mga stationary na mga coins na walang momentum, they will still be absorbing the momentum coming from that moving coin. Okay? And dun naman sa last na dalawang coins na pinagbangga mo, they will be absorbing each other's momentums. The momentum is only transferred to another body, or it is transformed into a different form of energy. So, dalawa lang siya. Pareho siyang merong chance over here. Like, there is kumbaga, travel, okay, from one thing to another. So, when the momentum was moved from one body to another, it was transferred. But if the momentum was transferred, pero merong mga parang kulang, halimbawa, parang hindi naman ganon kataas yung momentum na naipasa, like we're expecting this much momentum to be transmitted to the next body, pero hindi siya ganon kataas, parang it seems like hindi ganon kataas yung na-absorb na momentum ng body na yon, then we can say that some of the momentum was actually converted or transformed into a different kind of energy. Okay? Now, what do you call that? Kapag halimbawa, yung momentum is not created nor destroyed, or it's not never going to be gone. Like, it couldn't be destroyed. It couldn't just get lost. Hindi lang siya pwedeng nawawala. Kailangan lagi siyang may pinupuntahan. May mga times na hindi natin alam saan siya napupunta, pero surely may pupuntahan ang momentum. Okay? Now, what do you call that? You call the fact that momentum cannot be created nor destroyed as the law of conservation of momentum. And just like other conservational laws, it states that the total momentum of the objects before collision is the same as the total momentum of the objects after the collision, and it can be expressed mathematically as follows. So, the momentum before is equal to the momentum after. Alright? So, the amount of momentum na mayroon ang system nung una will surely be the same as the amount of momentum after ng collision. Now, let's learn more about this relationship in the next section. And you know that the next section is about ask. Okay, so under that tayo sa ask, this is where we formulate a question first, and then we discover something more about the topic. We explore something more about the topic. Now, I am sure that before we continue, you remember what momentum is. Ano yung meaning niya? Ano rin yung formula niya? And maybe you're now having questions, paano ba siya nako-conserve in the collision of objects if they have separate momentums? Now, what do we mean about separate momenta? Anong objects yan? Actually, we're talking about that last, those two coins, dun sa last example natin, yung pinagbangga natin. Yeah, you remember that? So if the coin coming from your right it has its own momentum, and the coin from your left has its own kind of momentum, if you like collide them, how is the momentum going to be conserved? Okay? Okay, so in our previous examples in book 19, dun sa momentum, impulse and momentum, we mentioned colliding cars and trucks and barriers. Now, do you remember the reasons why airbags and seatbelts must be used? Do you remember that? Okay. Now, this has something to do with the current question that I want you to formulate. Now, we'll be investigating why there are accident scenes when cars seem to have fused with each other. Di ba may mga, although this is a trigger warning, there are accidents when two cars collide, they seem to have been stuck with each other, right? Para silang nagdikit, right? Like they were connected because of the collision. And it seemed like they moved a distance after the collision together, right? 'Di ba? May mga ganun. Yung halimbawa, this car is speeding and and then another car is speeding, and then let's say that they met head on. Nag-stuck sila with each other, tapos yung isang car that has maybe a greater momentum, parang tinulak niya yung nakabanggaan niyang car towards the direction of its momentum, right? Now, we'll be investigating why, in some instances naman, cars meet in an accident seem to be like the coins we used in Activity 68. Like, may mga times naman na may mga cars na kapag nagbanggaan sila, they're just gonna be bumping or bouncing off each other. We're gonna be investigating that. Now, you have to think about the questions that you might have about those events, and you have to write it down. Okay? All right. If you need more time, you can pause this video so you'll be, stuck in this screen. I know that you might need some time to get your notebook or a piece of paper to write your question down, and write it down. Now, if you're done, let us now move forward dito sa last na part ng ating session. It's actually parang the major part of this session. Medyo mahaba-haba to. Okay, so bear with me. This activity kasi will help you in explaining how an object's momentum gets conserved in a collision. It's also going to enable you to solve problems on different types of collision. Now, you'll be needing the following materials: a piece of paper or sheets of paper, stopwatch, a basketball ball, a camera phone, pencil, a meter stick, tape measure or a foot rule or anything that you can use basically to measure, masking tape, and a calculator. But if you have a camera phone or maybe a smartphone, you can just use that. Alright. What is the first step? Using a meter stick or tape measure, you have to measure the height of 2 meters. If you do not have a meter stick or a tape measure available at home or wherever you are right now, you have to measure 7 feet of height. Okay? Mark the 2-meter height with a masking tape para alam mo, i-mark mo siya banda dito. Alright. Now, the second step is if you have a weighing scale, measure the mass of the basketball ball you are using in this experiment. Balls might look the same, but they might have, different masses. So, yeah, measure the ball that you're using. But kung wala kayong pang-measure ng mass niya, ng weight niya, the standard mass of a basketball ball is 623.7 grams. So, maybe you can use that. Okay? Now, position the ball in the 2-meter mark. I-position mo siya. Kumbaga yung sa may bandang baba ng ball, hindi siya nakagitna ha, bale. If the ball has its, the whole circumference, like if it's 2-dimensional, kailangan yung parang tip niya, okay, sa may bandang baba, is touching the 2-meter mark. Okay? Okay, now the basketball ball has to be released in that height, and you need to mark how high it bounces back. So you may need the assistance of a friend or a learning partner for this. If you do wish to do this by yourself, you can set up a camera phone to record the video so you can mark the bouncing height yourself. This is highly advisable. Okay, para mas accurate yung data mo, mag-setup ka na lang ng camera phone in such a way na nakikita yung mark, yung 2-meter mark, at makikita rin kung gaano kataas yung magiging bounce ng ball kapag nirelease mo na siya. Now, you also need to measure the number 1 or letter A, the time it took for the ball to reach the ground. So yes, a camera phone or a phone is really advisable. Like taking a video of it is highly advisable. And then B, the time it took for the ball to reach its maximum bouncing height. So yung first na time dito is yung pagbaba ng ball. And then second time naman is yung pag-akyat ng ball as it bounces up. Okay? Now you have to keep your stopwatch in split time setting, or you can just record the video. Okay? Okay, I hope that you're setting it up right now. Now you have to take note that smartphones often have this feature. In the absence of a stopwatch that can do split timing, some watch models have stopwatches, so maybe you can use that too. Now, the fifth step is you have to release the ball in the 2-meter mark. Record the height of the bounce of the ball in the following table. Also, you have to record other important data required in this table. So, yung 2 meters, binigay na siya. It's the height of the fall. Now, what's the mass of the ball that you measured? Kung wala kayong pang-measure ng weight ng ball, you can just use the value that I gave you a while ago. Okay, so for the first column over here, you have to record the time of the fall in seconds, and then the time of the rebound or the time of the bounce in seconds. Okay, and then the rebound height or the bounce height. Gaano kataas yung pagbabounce up niya. And then get the average. Alright, now for number 6, compute the velocity of the ball during the fall by dividing the height of the fall, h, by the time it took for the ball to reach the ground. Halimbawa, kung yung, for example, the height of the fall in this activity is always 2 meters, okay? If in the first try, the basketball ball reached the ground in 0.5 seconds, then this is going to be the velocity. Okay, simple lang siya. So again, distance over time. So distance is 2 meters, time is 0.5 seconds. You divide that, you'll get the velocity, which is 4 meters per second. All right. Now you'll be putting those the data over here. So trial number 1, number 2, and number 3, and then get its average. All right. For number 7, compute the velocity of the basketball ball during the bounce or the rebound as it reaches its bouncing height, yung maximum na height na na-reach ng bola nung nag-bounce siya. Now, use the distance between the launching of the ball from the ground until it reaches a certain height and the time for the basketball ball to get there. So again, may distance dyan, meron din time. Okay? Record the velocity over here. I am assuming now na alam mo na kung paano kunin yung velocity. Okay? You'll be dividing the distance by the time. Okay? Okay, in this case, anong distance yung gagamitin natin? Yung distance na na-cover ng bola nung nag-bounce siya. Ano ba yung maximum height na na-reach niya? Okay? Ano naman yung time? Yung time for the ball to move from the ground papunta sa taas. Okay? You'll get the velocity. Alright, now you'll be computing finally for the momentum of the basketball ball as it falls to the ground using the mass you measured or yung given mass of a standard basketball ball. You'll now, since you get the mass, you have the velocities as well. You can now compute for the momentum. You'll be doing the computation in all of these trials. Okay, so again, this is during the fall. Okay, so sa first trial mo, ano yung momentum ng bola nung pababa siya? You need the mass given. You need the velocity, sinolve mo na kanina. Okay? So I hope that you now are solving for the momentum of the basketball ball during the fall. Okay, so Next one, compute for the momentum of the basketball ball as it bounces off the ground, reaching its bouncing height. Now use the velocities you have recorded in the table in step number 7. Now I'm sorry, this is still during the bounce. Ay, no, no. Ay, tama pala siya. During the bounce na to. Yung kanina, during the fall. Ito naman, during the bounce. Hindi ko lang siya na bigyan na, ng effects. But, yeah. Ito naman yung momentum ng bola nung nagbabounce na siya, yung from the ground pataas. Alright, so ano yung momentum yun? Trial 1, trial 2, and trial 3. And then what is its average? Alright. Now, at this point, meron ka ng data for the momentum ng ball nung before it collides with the floor and after it collided with the floor, right? Alright, now, what do we do? Finalize your answers. Make sure that you follow the instructions carefully. You also, I hope, noted some observations. Now, if you have some clarifications, you can always read the instructions once more or ask for the assistance of an adult or a more abled peer. For the meantime, you have to answer the following guide questions. The first guide question is as follows. Question number 1. When the basketball ball was released from 2 meters, it gained a momentum until it collided with the ground. It bounced up. You were able to solve for the momentum of the basketball ball as it falls and as it goes up after the bounce. Again, you were able to solve for the momentum of the basketball ball as it falls during the fall and during the bounce. Now, which of those momentums is basically higher than the other? Or is any one of them higher than the other? Now, did the momentum of the ball stay the same before and after the collision? If you need more time, sige, ito yung question. If you need more time, pause this video. But if you are already through, you can move forward to the next guide question. Question number 2. If the values of the momentum of the basketball ball before the collision and after the collision stayed the same, kung walang nagbago, why do you think that is so? Was the momentum conserved in that case? Now, if the values of the momentum of the basketball ball before and after the collision changed, what do you think this is so? Is that change in momentum supposed to happen? If you need more time, pause this video. Now, if you're done, let's proceed to the next question. Question number 3. Instead of dropping the ball, what if you threw it downwards? What will happen to its momentum? Why do you think this is so? Now, finalize your answers to these guide questions. And let's check your work. Okay. For question number 1, the value of the momentum of the ball as it speeds down is higher than when it bounces up. Okay. Anong mas mataas na momentum? Yung habang pababa siya. Now, yung pagtaas niya, it's not usually higher. Okay, it's actually lower. Question number 2, the answer is the values of the momentums changed because the ball was dealing with gravitational pull that will always I'm sorry, that's a grammatical error, that will always make its downward momentum higher than its upward momentum until it eventually stops bouncing. Okay. Nung pababa yung bola, mataas ang momentum nun kumpara nung nag-bounce siya pataas. Okay, why was that so? Because nung pababa siya, it was actually reacting with the gravitational pull of the planet. Okay, it's accelerating 9.8 meters per second squared downwards. But as it moves upwards, nung nag-bounce na siya, it's actually moving against the gravity, okay? So, it's not going to perpetually bounce up, okay? It's not going to just perpetually bounce up like di na siya matatapos mag-bounce. Okay? Because what happens in reality is that it gets pulled little by little towards the ground by the gravitational pull of the planet. Alright? And then question number 3, if you are going to throw it downwards, meron kang application of force. Okay? Mas matindi, mas mabilis, mas mataas yung momentum nung bola kapag ganon. Okay? Bakit ganon? Dahil apart from the gravity that was acting on the ball, pulling it downwards, you also applied some downward force, making its velocity higher. Therefore, if you multiply a higher velocity to the same mass, it's basically going to result in higher values for momentum, right? But if you drop the ball, like just let it drop and let it react with pure gravity, it's simply going to have its normal momentum reading. All right, we're through with this part of the session, no? Medyo mahaba-haba ngayon and medyo masalimuot yon. I know that in each step, hindi naman like agad-agad may mga nailalagay kang sagot, okay? Pero, we're done. I'm happy that we're done. All right. Now, this is the 15th session and we're done with these 3 parts. I am hoping that you are keeping your notes together, and I'm hoping as well that you're not just passing by these video lessons, not really scrutinizing its component parts. I hope that for these 3 parts, malinaw na ang lahat ng mga kailangan nating i-discuss, kailangan nating i-tackle. Okay? Alright, this is Sir CJ and I hope that I will see you in the next video lesson. Have a good day.